Alright, welcome to my YouTube channel. This is Dramani Online Mathematics. Today we want to look at one of the interesting topic in the mathematics, both core math and elective maths. We are going to look at indices and logarithm. And when you say indices, is the power of exponent which is raised to a number or a variable. So, if you look at an example here, if I have 2 to the power 4 or 3 to the power x, this 2 is raising the power what? 4. This 3 is raising the power x. And we are saying that what is here is called exponent power or index. And the 3 here is called what? The base. Alright? So anytime you see something in the form like this, we call it what? Indices. Where you have a base and you have what? An exponent or an index or a power. We call that thing as what? Indices. Alright. Now let's look at laws of indices. First I have A. Now let's take note of something here. This is A. This is also A. The base must always be the same before this law will hold. The base must always be the same before the law will hold. And there must be what? Multiplication sign. So if the bases are the same, we can easily add their powers. So if I'm to add the powers, that will be m plus what? N. So let's look at an example. If I have 2 to the power 5 times 2 to the power 6, that will give me 5 plus what? 6. And 5 plus 6 will be 2 to the power 11. Very simple. Let's also look at this one. This is when they are multiplying. What of if they are dividing? If they are dividing, it's very simple because you check the base if they are the same. And once our bases are the same, and you know this is also the same as that, if they are dividing, we maintain the first one. So you take the power which is m here minus the down one. So we have m minus n, not n minus m. Take note, m minus n, not n minus m, because we take the numerator on minus the denominator. Okay. So let's look at an example. If I have 5 to the power negative 1 divided by 5 to the power 3, then we are saying that we should maintain this one, then subtract the powers, so which will be negative 1 minus 3. And this will give you 5 to the power negative what? 4. And I think this is very clear. So let's move on to the next one. A to the power m, or in brackets to the power n, means that this is power, this is also power, okay, with one base. So what you are going to do is very simple. You take the base, then you multiply their powers. So it will be m times n. So if I have this example here, 10 to the power 2 exponent 3 is the same as 10 to the power 2 times what? 3. And this will give you 10 to the power 6. This is very simple. Alright, so let's move to this one. This is AB. So unlike this one was one base, but this one with two bases, and the bases are different. You can see that these bases are different. So, and it's raising one power. When that thing happens, the power here will affect this and that. It means that this is a to the power what? M, and b to the power m. So that's what is happening here. A to the power m, b to the power m. So in case we have this example here, let's say I have 2y to the power 3 is the same as 2 to the power 3 times y to the power 3. take note that 2y means 2 times y. So AB means A times B. In terms of multiplication, when we are multiplying two variables, we can easily write them as AB, like AB or A times B, depending how you want to write it. Now let's also move to this one, the law number 5. A over B all to the power m. It's just behaving like this, just that this one is multiplication and this one is what? Division. The same thing, you distribute the power among them. So in case I have, let's say 2 over 3 all to the power half. So here will be 2 to the power half over 3 to the power half. So simple and simple as that. Now let's move to this one. I think this is the most common, law that a lot of people are aware of it. And this law is saying that any non-zero number raised to the power 0 is 1. So the number should be a non-zero number. So we are saying that this A should not be equal to what? 0. Because we know that 0 to the power 0 is undefined and you will not get an answer for that. It's undefined. So the definition for this is that any non-zero number to the power 0 is 1. So example is, if I have 1000 to the power 0, my answer is 1. So any number at all. Alright, now let's also move to this one. A to the power negative m is the same as 1 over a to the power m. Very powerful law, because this law, we are going to apply it a lot and you have been seeing it. Maybe you don't know that it's coming from this point. So let's look at how we can go about this one. A to the power negative m is 1 over a to the power m. So you take the inverse, just like taking the inverse here. So what is happening here is that, let's say if I have 5, let me use this. So I have 5 to the power negative 3 is the same as 1 over 5 to the power 3. And this is very beautiful law that we are going to use it. This law too says that a to the power m over n, so the power is fraction. You can write it as, you can decide to factorize the m out. If I factorize them out, I have 1 over n, then this one is out. And from here, you can see, if I want to get back this, I simply multiply this one by that. That will give us this. And that one is coming from this law. Okay, so this one we are talking about. If I have 2 to the power, let's say 3 over 5, I can write it as 2 to the power 5, 1 over 5 times 3, like this. And this are the laws of indices that you have to know and be used to it. Be at your fingertips, so that when you see a question, you can easily apply them. Now let's look at an example. If I have simplify 5 to the power 3 times 4 to the power 2 times 5 to the power 6, all divided by 4 to the power 8. Okay, this is an example. If we want to do this, let's see how we can go about it. Alright, so let's look at how we go about this. So we have 5 to the power 3 times 5 to the power 6. This and that have the same base, so I can put them together to have 5 to the power 3 times 5 to the power 6, then times 4 to the power 2, all divided by 4 to the power 8. Alright, so from here, this and that have the same base. So we are saying that if they have the same base, you simply do what? Add their powers. So from here, I can have 5 to the power 3 plus 6 multiplying by 4 to the power 2, all divided by 4 to the power 8. So once I'm adding their powers, that will give us 5 to the power 9. And you see this and that. I can write it this way: 4 to the power 2 over 4 to the power 8. But this is multiplication, so you can easily write it this way. So from here, the same base and they are dividing. So the law says what? When they are dividing, you subtract their powers. So 5 to the power 9 times 4 to the power 2 minus what? 8. So 5 to the power 9 times 4 to the power negative what? 6. You can still simplify this one further, because we said that one of the laws is saying that if you have something like this, I think it's here, you write it as 1 over that. So this one can be written as 1 over 4 to the power 6. So this one become our final answer. Okay, so you can break this one down, that one if you want to. Okay, now let's also look at another example. Alright, so the question is saying, evaluate x to the power 5 times this times that all over that. So what you're going to do is that after that, you just substitute the value of this into it. That's all. Very simple. So first thing, first you have to be able to identify this and that. You see, they are the same, so you have to be able to identify that. So x to the power 5 times x times y to the power 2, all divided by y squared times x cubed. So from here, this and that, this is with power 1. So x and x have the same base. So I'll write it down. Then I'll add their powers. 5 plus 1 will give me 6 times y to the power 2, all divided by y to the power 2 times x to the power 3. So you see this and that is dividing that, this is also dividing that. So I can write this one as x to the power 6 over x to the power 3 times y to the power 2 over y to the power 2. So since this and that is dividing and they have the same base, you simply subtract their powers. Here, the same thing. So this will definitely give you x to the power 3 times y to the power 0. Now the question said, evaluate when x is 2, y is 1. Straight away, we know from a law that any number to the power 0, non-zero number to the power 0 is 1. Therefore, let's substitute the value of x here. That will give us 2 to the power 3 times 1. 2 to the power 3 is 8 times 1, and you have what? 8 as your final answer. Okay.